In this video, we want to look at inverse normal. Now, just to refresh our memory on what we looked at in the last section, we said if we had our normal curve and we had our z value of, let's say, negative 1.25, we would say that's from here, and we look up in our chart and we'd find this area to the left of negative 1.25. And if I would go to my chart, negative 1.25, I would get 0.1056. So that's what we looked at last time. This time, we want to kind of just reverse it, which is why it's called inverse. This time, we're not going to have the z. We're going to be given the area, and then we have to find the z. So it's kind of like going backwards. So let's look at an example. What z separates the bottom 10%? So what that means, wherever the line is, we're just going to guess. We know if this is 0, to the left is 50, so 10%, we're just going to guess, doesn't really matter where. We're going to say this bottom percentage here is 10%, which would be 0.1000. And I'm writing all 4 decimals because when you look in your table, they give you 4 decimals. So now what we want to do, we know this z over here, whatever this z is, we know it's on this side of 0, so we know it has to be negative. So flip your chart to the negative side, and you want to go through your chart and try to find 0.100. So as we look through our chart and we get to 0.100, you will notice that we can't find it. It's not exactly on there. But if you look at your chart and you go to negative 1.2, you see 0.0985 to 0.1003. And if I go all the way to the top, this is 0.09, and this is 0.08. So the value we're looking for is in here, 0.1000. So when we pick this value, we want to pick the one that's the closest, whatever one is closer. So in this case, that's going to be 0.1003, so our z is negative 1.28. Now, one way I like to think about this, I'm going to kind of use my terminology here, and this may make sense. It's how I like to think about it. I like to let's ignore the decimals for a second and say I am looking for 1,000, and I have 2 numbers, 0.985, 1,003. And then in my mind, I think this way. This one is over by 3. So it's plus 3. This is over by 3. This one is under by 15. So that's how I like to look at these. When I'm looking for a specific number, I think of all 4 digits, kind of ignore the decimal points for a second, and say, which one is it? And then when I'll say, I'll go, one is under 15, one's over 3, so the over 3 is the one we go with. But when I use that terminology through the rest of this video, you understand what I'm talking about. Now, the next one. What separates the top 10%? So what value here would give us the top 10%? And there's 2 ways to think about this. Let me go the longer way first. Remember, our chart is always the area to the left. So if it's 10% to the right, that tells me it's 90% to the left. So when I find my z, I'm going to look in my chart, and I'm going to look for 0.9000. It's probably not in there, so I'm going to have to find the closest. So I flip it over to the positive, because I'm to the right of 0. And I look for 0.900. And I'll show you where I'm at here. The 2 I get are 0.8997 and 0.9015. This is 15 over. This is 3 under. So I'm going to go with that is the closest. And if I look in my chart, that's going to give me a positive 1.28. Now, some of you might already realize these graphs are symmetric. So if we know that a negative 1.28 gives me 10 to the left, that's going to tell me a positive 1.28 is going to give me 10 to the right. So that's an easy way you could have done this. Instead of doing what I did here and looking for 90%, you could have said, well, I know if I want 0.1 to the right, I just look for 0.1 to the left. I see a negative 1.28 in my chart like we did in the last example, but I want the opposite of that, so I get to the positive. Now, if that doesn't make sense, ignore everything I just said the last 30 seconds and just look for the 90, and you will be perfectly okay. So get another one. Find the z-value described and sketch the area described when 13% is to the left. So we always want to kind of sketch these so we understand 13% to the left, so that means it's less than 50, so that means we're over here on the left side, right, because zero's in the middle. So I'm going to look in the negatives for 0.13, and if I go through, once again, I will write down the two numbers so you kind of see where I'm at. The closest I can see is 1.292 to 0.1314. This is 8 under. This is 14 over because we're looking for 1300. And if I go over, this is negative 1.1. And at the top, I have 0.3 and 0.2. This is the closest. So my answer is negative 1.13. So we're using the same chart we looked at yesterday. We're just using it in reverse. Let's try another one. To the left of 75. Okay, so here's our 0. So now we know if it's 75, we need to be over here, because we are this side of 0. So if I go to my positive z's, I look for 0.75. And once again, I'll show you the closest I can get. IPC 0.4786, 0.7517. This is 14 under. This is 17 over. So this is my closest. And that would be 0.6. 0.07, so my z here would be 0.67. Now, if we have one where it says to the right, like we talked about, we have 18% to the right. We subtract that from 1, and that tells us to the left is 0.82. So we are going to look for 0.82, which would be positive. And if I look for 0.82, I see 0.186 to 0.82112. This is over 12. This is under 14. So this is the one I'm looking at. And where did that go? That gives me 0.9 to 0.2. So this would be 0.92. Now, the other thing we can do is if we have something like this, let's look at 5% to the right. So we have 5% to the right. And once again, that gives me 95% to the left. So if I look for 95, I get this. I get 0.9495 and 0.95 0.05. So what happens is this is under by 5, and this is over by 5. And I am at 1.6, 0.04, 0.05. So when we have this situation and it's absolutely perfect right in the middle, we're going to go in between these and say 0.45. So we get 1.645. This is the only time we go to 3 decimals. This is the only time we divide it in half when it's exactly equal both ways. The next kind we want to look at is when we have something in the middle. So we've looked at percents at the right and the left tail. What happens if we have a percentage 82% in the middle? So if we have 82% in the middle, that tells us we have 16% left over in the two tails. That means if we have 16%, that means we have 8%, 0.08, and we have 8% over here. So what we have to do is go to our Z, and we're going to look up 0.08. And if I do that, I can get, let me find it, 0.08, and the closest I get is negative 1.414. Now, if I find that, I could go and figure out the other one. But when we're doing this Z, what works out is this over here, as we said, is symmetric. It's the exact same thing. I don't have to find another one. These are the same Z. If I have 8% to the left or 8% to the right, one is positive, one's negative, but they're the same number. Let's try another one. 76. So we have 76 in the middle. We subtract that from 100, so 76%. That tells me there's 24% left. That tells me there is 12 on this side, 12 on this side. So now I look up 12, which is 0.12. And once again, I am in one of these situations where I have two numbers. So I have 0.1190 and 0.1210. And this is at negative 1.1, 0.08, 0.07. So I go right in the middle, and I get 175 and a positive 175. So if you are doing one of these where it's the value between the Z, you're going to get two Z values that are the same numbers. You could even say Z is plus or minus 1.175 if you wanted to, because they're going to be the same number. If you have something where you shade to the right or to the left, you're only going to get one Z when you look at this. All right, here are three for you to try. Go ahead, pause the video. You can try these three, and then we'll come back and look at the answers and see if you can see if you got them right. All right, so here are our answers. The first one, 0.052, we get negative 1.63. For the right of 0.35, we get Z as 0.39. And then I realized I was doing the answer one. Hopefully every single person got part C right, because part C, plus or minus 1.175, was just the exact last example we just did. I didn't realize I forgot to change the number when I cut and pasted that problem down there. So hopefully everybody got that one right. All right, you are now ready to work on some problems over inverse standard normal distribution.